And the best way to understand what these directives really are is to first go one level deeper and understand the steps involved in pre-processing, compiling, assembling, and linking C programs. Throughout this conversation, it's important to keep in mind C is a compiled language. The source code, which is typed out by the developer, is going to be converted to the binary executable file via these steps. And once this executable has been created, it can then be run in order to execute the program. Compiling our code into the executable and then running that executable are two entirely distinct steps. This makes C quite different from other languages such as Python, which are interpreted, where there is no explicit distinction between running the code and interpreting the code, as well as other languages like Java, which have an intermediate step which involves the creation of bytecode to achieve platform independence. Broadly speaking, we can categorize this process of going from the source code to the executable as having four main phases. The first phase is performed by the preprocessor, the second by the compiler, the third by the assembler, and the fourth and last by the linker. Let's start with the preprocessor. This is a phase of compilation in which the preprocessor takes in the source code that was typed by the developer and performs a few preparatory operations. The input into the preprocessor is the source code, and the output is also source code. However, this output source code is preprocessor output, and it's not all that easy to read. In the demos coming up ahead, we will examine the output of the preprocessor in some detail and use this as a tool for figuring out how exactly our program has been put together. The next stage is the compiler stage. Here, the high-level source code, which was output by the preprocessor, is going to be converted to assembly code. Assembly code is specific to the particular platform on which this code is being compiled, and in this way, C is not platform independent, unlike, say, Java, because there are additional intermediate steps. The compilation leads to the creation of bytecode, which then can be interpreted by the JVM on different architectures. There's no such step in C. You are very close to the underlying hardware and platform when you write C code. Assembly code is not quite the same as machine code. Assembly code often consists of opcodes or mnemonics, which then need to further be translated to one lower level, and that lower level is the machine code. This machine code can directly be executed on the target computer on which we are running our program. Assembly code is certainly understandable by humans, and indeed for many decades it formed an important part of the repertoire of a developer. Machine code, on the